Viruses are very tiny objects. They have a size of about 100 nanometers or so. Therefore, they are 100 times smaller than thickness of a human hair. The most conventional method of detecting viruses includes obviously taking a sample from a patient and putting it in contact with in vitro cells. The researchers then observe which kind of damages the viruses cause when invading the cells. And then the damage caused by a given virus is virus-specific. The problem, however, with that technique is the time it takes to identify which virus a given patient is infected with. It might take even a week to wait for results, which is really, really long.
1 and 2.
So our technique, which we are developing in a close collaboration with the Livermore National Laboratory, will be both fast and will be inexpensive. It will be fast because the detecting principle is extremely simple and is already sensitive to a single virus. The key element of our device, which we are building, is a membrane, which you can think about as a barrier through which nothing passes through. But that barrier has one opening in it through which things can pass through, and we will call it a nanopore. Now, if that barrier, if that membrane separates two chambers filled with a water solution of a simple salt, for instance, kitchen salt, the salt will want to pass through the nanopore if the whole device is connected to a battery. Now, the salt passing through creates signal, which can be easily measured with off-the-shelf equipment. The signal we call current. Now, imagine that you have a virus in the solution as well. Well, the virus will want to pass through the nanopore as well, but it's much larger than the constituents of the salt. So even a single virus will cause obstruction of the nanopore, and the level of it will depend on the type of the virus. That's a very simple method of detecting single objects. The technique is fast because it can detect already a single virus. And the technique will be inexpensive because all the components which will become a part of the device are very inexpensive as well. So one of the experiments which are planned in the near future is to perform our analysis with killed influenza virus to provide the proof of principle that indeed the viruses can be detected. Right now, we are not working with viruses per se. We are working with model systems, which you could imagine they are like little particles, which are very tiny, but the size is comparable to the size of viruses. We are in fact very optimistic that the method which we are developing for viruses can be very easily and quickly and cheaply introduced into hospitals. The technique would be so fast that one could imagine getting an answer within an hour, and that's a pessimistic estimation.